This next unit is all about right triangles, and with right triangles, remember that we can use the Pythagorean theorem. So you've seen the Pythagorean theorem before, and now we're going to also add in that converse. But starting with our Pythagorean theorem, remember that we use it to find the missing side of a right triangle. In the picture on the left, sides A and B are called my legs. Those are the sides that are sandwiching my right angle. And side C, the side across from that right angle, is my hypotenuse. Pythagorean theorem formula is a squared plus b squared equals c squared. So just a couple of basic examples. For number one, we see that we were given our two legs and we want to find the hypotenuse. When we write out that equation, it's 8 squared plus 13 squared equals x squared. When we solve, remember we're going to simplify the left side, and then to undo a square, we square root both sides, and we have our decimal approximation as 15.3. In this case, it did ask us to round to the nearest tenth. Sometimes it might ask for the hundredth. Number two is the same way. We were given our two legs. I know they're my legs because they're the sides sandwiching my right angle. And I want to find that hypotenuse. So I'm finding my C. When I solve, I get my decimal approximation. Number three is an example where we're finding our leg. So they gave me my hypotenuse and they gave me one of my legs. When we plug it in, it doesn't matter where you put the 7 and the x. Either way, they're both going to go on that left side. So you can write it as 7 squared plus x squared, or you can flip it and do x squared plus 7 squared, and that's going to equal 9 squared. When we solve, again, we're going to get a decimal as 5.7. 4, we're also finding our missing leg here, so they told me my hypotenuse is 30.5, and they told me my leg is 19.1. When I find my missing leg, I find that it's 23.8. So there's some more basic examples. We're going to do slightly more complicated examples now. When we see that we were given a large triangle and we want to find the side of x. In this case, they didn't tell me that I have a right angle in the corner up top, so I can't use the Pythagorean theorem with 14, 29, and x. What I need to do instead is use the two small right triangles that were formed inside this larger triangle to figure out what A and B are, and A and B make up my x. So I have my first small triangle on the side here, and I'm going to label the bottom leg A so I can find that length. When I do that, I have 12 squared plus A squared equals 14 squared, and I find that A is 7.2. We're going to do that same process finding B, so the length on my larger right triangle on the inside of the big triangle. I'm going to write out my equation, and I'm going to solve and find that B is 26.4. Now I want to find the entire length of x. X is made up of A and B, so I'm going to add them together to find that the full length of x is 33.6. Again, we had to break it into two smaller right triangles because we didn't have a right angle at the top for number 7. For number 8, we want to find our value of x, but before we can find our value of x, we need to find this missing side in the middle that I've labeled y. The reason we need that is we need two pieces of information before we can use that Pythagorean theorem. So I'm using my length for my leg and for my hypotenuse to find this missing side here, what I've labeled y, which is then going to be the leg for the triangle that I need to use to find x. When I set up my equation, I have 10 squared plus y squared equals 25. 25 is that hypotenuse across from my right angle, and I find that y is 22.9. Now that I have the length of this leg for my triangle that I can use for my x, I can set up the Pythagorean theorem using that. So I'm going to do x squared plus 22.9 squared equals 28 squared. to find that x equals 16.1. So I had to do an extra step before I could find that x, but just using the same Pythagorean theorem with a different right triangle. For number 9, we see that we were given a trapezoid. Within my trapezoid, we see that we have a rectangle and then 2 right triangles on the side. Our goal is to figure out x, so x is both the width of my rectangle in the middle, but also the side of my little right triangle. In order to do that, we need to find some information so we can set up the Pythagorean theorem formula. We see that we have our slash marks on the side, and one side was labeled 20. So remember that that means that both sides are 20 from our congruent triangle unit. So I know that my hypotenuse is 20, and now I need to find that missing leg. They told me that the top of the trapezoid is 26. If I look at just my rectangle, I know that opposite sides of a rectangle are congruent. So that means that the middle piece is 26. They told me that the entire bottom of my trapezoid is 40. So if I subtract 26 from 40, I find that there's 14 left over. That 14 needs to go to my little triangle on the left and my little triangle on the right. So when we cut it in half, that means that each piece is 7. So that's why I've marked it with 7 there. Once we find that missing piece, we now have 2 pieces of information for a right triangle, and we can set up the Pythagorean theorem to find our x. So when I set up that formula, I'm going to have 7 squared plus x squared equals 20 squared. And solving for x, I find that x equals 18.7. We are now going to take a look at a couple of word problems. Our word problems we do the same way. We just have to set up that picture first so that we can set up our Pythagorean theorem from it. For number 10, we have that a roofer leaned a 16-foot ladder against a house. If I'm leaning a ladder against a house, that's going to be my hypotenuse. Then it says that the base of the ladder is 5 feet from the house. So that means the bottom of my ladder to my house is 5 feet. That's why I have 5 on the bottom. And we want to figure out how high up the ladder reaches. So that is our x. We're trying to figure out that distance there. When I set up my Pythagorean theorem, we are going to solve, and we find that x is equal to 15.2. Since this is a word problem, our final answer needs to make sense with our problem, so we need to add a label. In this case, x is standing for feet, so our real answer is 15.2 feet. That's how high up it reaches on my house. For number 11, Kurt has a rectangular desk, so we're starting with our rectangle. The dimensions of the deck are 10 by 23, so those are our sides. Remember, width and length, it doesn't really matter which is which on a rectangle. And we're figuring out the length of our diagonal. If I'm figuring out the length of that diagonal, in this case, we're finding that hypotenuse. So writing that out equation, we have 10 squared plus 23 squared equals x squared, and we find that x is 25.1. Again, we need to interpret that answer with our problem. So in this case, 25.1 is 25.1 feet. Number 12 is done the same way, so I'm just going to show you that work and those answers. But when we draw out our picture, we are just going to draw it out as we go. So the 3.4 miles east and 5.7 north or south, and then we are finding the distance. That was for Pythagorean theorem. Now we're going to look at the Pythagorean theorem converse. So with our converse, we are going to be able to decide what kind of a triangle it is. If we have that c squared is equal to a squared plus b squared, then that means we have right triangles. That's our normal that we've been doing. The new things come in with looking if triangles are obtuse or acute. If c squared is greater than a squared plus b squared, that means that our triangle is obtuse. If c squared is less than a squared plus b squared, then that means those triangles are acute. So looking at a couple of examples, we are going to start with our lengths. They'll give us 3 lengths. Whichever length is the longest is what we're assuming to be our hypotenuse, our C. When we look at our triangles, we do need to decide if it can form a triangle first. So we're using that triangle inequality theorem from a couple of units ago. Remember that we're adding the 2 smaller sides, and if the smaller sides added together are greater than that third side, then a triangle is formed. So in this case, 3 plus 7 is greater than 9. I know that a triangle is formed, and now I can figure out what kind of triangle it is. When we do this, we're going to start with squaring the 9. And then on the other side, we're going to square 3 and square 7 and add them together. 9 squared is 81. 3 squared plus 7 squared is 58. When I compare those two numbers, I see that 81 is greater than 58. If my C squared is greater than A squared plus B squared, then that means my triangle is obtuse. Same thing for number 2. We're going to start with that triangle inequality theorem and see if a triangle is even formed. When we do that, 20 plus 21 is definitely greater than 29. And then I'm going to set up my little formula or my equation. So I have 29 squared on one side and I have 20 squared plus 21 squared on the other. I see that I have 841 and 841. Since those numbers do equal each other, my C squared equals my A squared plus B squared, and that means I have a right triangle. Number 3, we're starting with that triangle inequality theorem. 4 plus 11 is not greater than 16. In this case, a triangle is not formed and I can completely stop. I don't have to decide anything else. Number 4, 22 is my larger side, so I'm going to add the smaller sides together. 17 plus 17 is larger than 22, so I know some type of triangle is formed. Figuring out what that triangle is, we're going to do 22 squared and then 17 squared plus 17 squared. When I do that, I find that the left side is 484 and my right side is 578. In this case, my C squared is less than my A squared plus B squared. If it's less, then that means my triangles are acute. We're going to do a couple more examples. So for number 5, again, starting with that triangle inequality theorem, 18 plus 24 is greater than 30, so I can keep going. I'm going to do 30 squared on one side and 18 squared plus 24 squared on the other. In this case, the two sides are equal to each other. Remember, if it's equal to each other, then that forms a right triangle. Number 6, starting with our triangle inequality theorem, we see that 18 plus 5 is not greater than 23. So again, we're allowed to stop and just say that there is no triangle that's formed. Number 7, we're going to add the smaller sides, so 31 and 35. That's greater than 39, so I can keep on going. I'm going to do 39 squared and find that it's 1,521. On the other side, 31 squared plus 35 squared gives me 2,186. When I look at this problem, my C squared is less than my A squared plus B squared. If C squared is less than them, then that means that it's acute. Our last example is number 8. I see that a triangle is formed, and when I find it, my C squared is greater than A squared plus B squared, so my triangles are obtuse. So again, the new piece of information is deciding whether a triangle is right, obtuse, or acute, and we're comparing our C squared to our A squared plus B squared. So that's going to be our key bit of information that we're going to need to remember when we're looking at the Pythagorean theorem and its converse.